This is our industrial engineering capstone project with general grind and machine. Our project is cost of poor quality estimation model in spring 2023. My name is Mason Ekblad and my other team members are Isaac Grindinger, Tony Lane, and Brady North. The objective of our project was to identify and calculate cost of poor quality factors that will aid GGM in reducing cost of poor quality by 10% each year for 3 years. This is the goal set out by GGM and we hope to accomplish. So methodology is we started with the PAF model, the preventative appraisal and failure. This is the cost of quality overall, but we focused on the cost of poor quality, which encompasses failure costs. Failure costs are things like scrap and rework that are a result of failed quality. To start, we did research on the PAF model overall and found about 200 factors that can contribute to failure costs. Then we narrowed this down by conducting interviews with over 20 staff members at GGM and following parts throughout the facility. From there, we calculated some initial factors in our project, and this narrowed down factors that were able to be calculated, and we did data acquisition as well. We narrowed this list of 200 factors down to 16 for our final model. Our final COPQ model. On the right, you can see the COPQ factors, all 16 of them. Some of them are internal scrap, external rework, reinspection, and retraining, and many more. As you can see on the right, that they're delineated from external and internal factors. We chose to do this because there's a big difference between scrap that is caught by a customer versus scrap that is caught by an operator in the plant. And we wanted to make sure those differences were highlighted for GGM to consider where their costs are really coming from. Some key assumptions were operating costs, so we wanted to make sure that the cost wasn't just the operator's time, but included running the machine, lights, everything. We also had two different versions of our model, opportunity cost and overtime. These represent the opportunity cost of making a bad part. When you make a bad part, you could have been making a good part. And so we represent that as opportunity cost. There's also overtime. If you make a bad part, sometimes you have to make that part on overtime. We use these as our max and min for our model costs. There's also material costs. These were heavily estimated, but do provide important information for our model. Our model is not fully complete as of this presentation. We were not able to calculate some of the factors, but we still believe this model is useful for GGM. And if they wish to complete the factors, they can do so as well. Our model in action. This is our model in action. We developed an Excel tool that will provide clarity and insight into COPQ month to month so GGM understands where their trends are going and if they're reaching their goals of reducing COPQ by 10% each year. What they do is they input factors into the Excel, things like cost of scrap, time spent on scrap, etc. each month, and it outputs COP charts like this rolling 12 chart example, bar graphs, total 12-month charts, monthly and quarterly charts as well. This is so GGM can visualize if they're meeting their goals and how their process improvement projects are helping them. The graph shows both opportunity and overtime costs as the max and min green lines. There's also two dotted lines on the graph as well. These represent the max COPQ per month that GGM is willing to spend and the minimum reduction goal. So that's where they want to go. The results of our project are we estimated COPQ for 2022, and we found that internal scrap was the largest factor at 62%. We also found that COPQ for GGM is between 10 to 11% of total sales. This is pretty good. That means they're on track, but they could definitely reduce it, as we found the industry standard is between 6 and 20% of COPQ prior to a quality reduction program, which GGM hopes to implement after this project. Our impact was we benchmarked COPQ for them for 2022, we identified factors for improvement, internal scrap, and we made an Excel program for them to track COPQ in the future. We also started the basis for a company-wide program for them to really improve their quality. The economic impact of our project is a net present value over 3 years of between $1.3 and $1.6 million. Thank you, and that is our presentation.